talk about some of the concepts that you'll need to know for your truss design project. First of all, you can see that the screen is set up just like your design project is going to be set up. We have a pin connection on the left side, a roller connection on the right. The weight is at a midpoint between those two connections, and it will be applied at a joint. And so I'm going to start out just by sketching in a simple triangular shape. We can test the truss, and we can see that it worked. It scored 110. The weight of our truss is 22. We can see that the blue members there, those are members that are in compression. The red member is in tension. And so one thing that we can do to try to make this truss more efficient is we can decrease the moment of inertia of each of the members, which decreases the cross-sectional area. And so I just made the members smaller. I can go ahead and test it this time. And you can see that the members that were under compression broke. They failed. When a member fails under compression, that's called buckling. And so those members buckled. When a member is under tension and it fails, that's called yielding. And so our two members under compression, they buckled. And so there's a couple of things we can do to fix this. One, easy thing to do, increase the moment of inertia by making the cross-sectional area larger. And so we can try it now. You can see that our truss worked a little bit better. We went from a weight of 22 to a weight of 17. Let's see if we can decrease the member under tension some more before it yields. Oh, good, and it still doesn't yield. So we decreased it from 17 to 15 now. And that's pretty much it, unless we want to make some design changes to this truss design. And so that's as efficient as this design could be. And so really we have to deal with these members under compression. So what that told us is that members will always fail under compression before they'll fail under tension. And so another way that we can fix the problem of these members buckling under compression is by decreasing the length of them. And I'm going to do that by adding a joint. So I decrease the length of each member. When I do that, I'm going to add in some support here in the middle section of our truss. Decrease the moment of inertia of those members, and we can test the truss. It works, weight of 17. Let's see if we can decrease them more. Still works, weight of 11. And so we've gone from a fairly inefficient truss to a pretty efficient truss by using some of the properties and concepts of compression and tension forces. Let's try one more time. We'll decrease the area of those members. Oh, and they failed that time. They buckled. This one buckled and this one buckled, and so we'll make them bigger. Now the ones directly above it buckled. And so you can see that when the buckling happened on those members, that the first time it happened in the ones closest to the connections, and when we just increased the one closest to the connection, the compression force just followed it on up the truss and broke at the next one that was under compression. And so that's one of the things you'll have to learn. So the only thing we could do to this truss now to make it more efficient is decrease the length of the members under compression. And so that's something you're going to have to think about when you're designing your truss.